Good afternoon. Christoph said everything that is important. I'm a guest today. I will report from a perspective of a researcher in machine learning and somebody who's looking on topics in digitalization, also from the perspective of one of your NTNs. And I try to merge the two questions that you will ponder in that breakout session into the title of that talk. And how we will approach that is basically we will look at some properties of digital innovation, namely these ones, and look at examples and some observations from the examples that I have made in my career so far, and will hopefully come to some hypotheses from my side and then the discussion from your side on, I hope that it helps you spin off an interesting discussion and bring you good insights. I planned roughly 30 minutes for that. Let's see how it went. So what are properties of digitalization? That was what I was questioning myself when Christoph approached me with the idea of presenting something here for you. I thought, okay, let's start off easy and say that digitalization as a property, innovation in digitalization is interdisciplinary. I want to do it this way for all the other properties as well. I will present you what I roughly mean with that, show you an example from what I have seen in an Innosuisse/CTI project, and then draw some observations from that. So what can we say about interdisciplinarity? I think it's pretty straightforward to say that innovations and digitalizations are often interdisciplinary. Why that? Because projects in an innovation and digitalization are often driven by some technical advancement, but this advancement is usually not the core of the company that is affected. The thing that is affected might be a product in building hardware, might be a medical process, might be a business idea, but at the core there are often technical things. And that means people have to work together. Technical people, engineers, computer scientists, hardware builders, sensor people, and on the other hand, business model people, subject matter experts. When we go a little bit more specific in areas of digitalization, talk about data science, then we have the term of a data product, a product or a service that is enabled because at the core we analyze data and leverage it in a way that it produces some benefit. And these kind of data products are usually always an interdisciplinary endeavor to develop. So this is why lots of digital innovations have some interdisciplinarity at their core. An example project that CTI/Innosuisse funded and that has been finished beginning of this year was the Complexity 4.0 project that the University of St. Gallen acquired and had the my lab and some other colleagues from ZHAW as junior partners. And it was a project in the area of trying to get rid of the bad sort of complexity in product variability. The goal was, we have had two business partners here that like not to be mentioned in public too much, that are producing goods, technical goods. They're producing machinery, and their machinery is like they have some types, but usually there's a whole lot of variability in their product. So kleine Losgröße in German. And the goal of the project was to determine what kind of variability in the product is good and needs to be retained for the sake of the customer, and what variability is not good, is just adding to complexity and needs to be removed. And the usual approach would be to get a horde of consultants with black suits and ties to horde into the company, go to the shop floor, look at everything, talk to everybody, make everybody nervous, and in the end, give an advice to management. And the idea in that project was, is it possible to do the data-driven? Can we take some data out of the processes that are already there, out of sensors, to get a feeling for which kind of variability is there and what can be compressed? And I think an important factor in that project was that people with different backgrounds work together. We had two different business partners, two completely different environments, different products, different variability. We had the people with a the economists with a background in technology management business models, data-drivenness from a management perspective, and we had engineers and scientists with a background in how to create simulations and how to learn from data. And interestingly, what came out was there is a way of learning from data that can tell you you have so and so much unwanted variability that you should get rid of. I don't want to go too much into the details because it's not about the project today, but what I want to tell you is I think it was an interdisciplinary project team that helped here. It was not just one expertise, it was different, and it was not just expertise on this side, it was also on the side of the business partner that was important. My first observation here, does that work? Yeah. Interdisciplinarity as a property of digital innovation is something that Innosuisse can deal with already quite well. We had a project, it worked. I've seen other projects where it worked. I think this is not so much an issue where you have to focus on when you think about what do we have to change something to support industry. So interdisciplinarity covered. Very good. What is with the other things? This was just to warm up. What is with scalability? Let's look at scalability and the property of digital innovation that is automating things together. Why? Because this is, I think, from my perspective, what is at the core of very many, if not all, digital innovations I've seen. Digital innovations usually mean you want to automate something, and as soon as you've automated it, because it's digital, because you do it with the computer as a tool, you can scale it. You can clone the program, you can copy it to somewhere else, and you can scale it up. Why? There are basically two technological drivers in that. We have what is now again called artificial intelligence, what is from a point of the discipline of artificial intelligence completely correct, but leads to some misunderstandings in the public. We have seen breakthroughs in the area of artificial intelligence in the recent years, namely in the area of pattern recognition. You all heard about deep neural networks, which is what part of my group is mainly focusing on. This is a method that works very well on pattern recognition problems, recognizing what is seen on an image, what is heard in a sound, how to generate images, how to generate sound, all these kind of things that we as humans are usually very, very good at, and that we can do effortlessly, and what up to 2012 maybe computers really sucked at. And now computers are good at that. At least we can make them good at it if we carefully engineer it for a specific project. And since we have that, we can automate much more tasks than before, because we can automate things where usually the perception skills of a human were required. So this is why automation has grown big and that automation depth has increased. Cloud computing is one of the technologies that helps that it can scale. As soon as we have capabilities on a machine, on a computer, we can just scale it up by renting more machines. We don't have to buy them, we don't have to buy housing, we don't have to have staff that manages the machines, we can just rent them in the cloud. And so we can scale up very easily. Let's look at a project where we have seen that, or even at two projects. The Libre Project currently running is a project where it's about MLD4 compliance, anti-money laundering. So you maybe know the legislation changed, and now companies, banks, jewelries, whatever is selling high-priced goods are forced to do a background check of their customers and don't sell to customers that are on sanction lists and are potentially related to people on a sanction list. In Switzerland, I don't know who might be on a sanction list, but in Germany, maybe Putin might be on a sanction list. So you are not allowed to sell a house to him or open a bank account for him. So the software here should help doing a quick background check on customers by means of checking the name that can be spelled in different ways against the database, and by checking the face on the passport against the database. So we are talking here in the background about face recognition technology. Face recognition technology, if you have looked a little bit into this scientific discipline, you know Google has produced a great paper on that in 2014. So Google is working on face recognition, right? Have they solved it? If they would have solved it, we wouldn't need that project. So obviously it's not solved. even if we are building on their FaceNet called technology. Our project partner here, Deep Impact, is a small startup from the Winterthur area. If that project succeeds, a small startup in Winterthur will have the best developed face recognition and anti-spoofing technology available on the planet. Will that be usable only in Winterthur? No, it's scalable. It's pattern recognition technology that can recognize things on pictures, and it works on a computer, and it can work everywhere. What is their market? Not just the Winterthur region, you bet. It works everywhere. I have a nice video here how it works, but it maybe takes too long. We will skip it. And look at another project example. With a not necessarily a startup, 130 years old company from Zurich called Argus. They do media monitoring, but they're a small company. They're maybe a rough 150 employees, something like that. They wanted to build a new product 2 years ago for automated print media monitoring. So if you have a high-profile job, you maybe in the morning get a press map from your consultant with all the news articles about yourself from the last evening. I've never got something like that, but people get it. Our school gets it. For once a month, we see where our school has been in the press. Argus is presenting doing something like that. How do they do it? Of course, they digitize newspapers and they look for keywords. But then in the end, they cannot just give you the page where you appeared on, because this would be a fraud, a copyright fraud. They have to extract the article from the page. How do they extract an article? I've been in their production environment. They have people there that are so skilled with computer mice, they can cut an article within a blink of an eye, literally. I was amazed. They would be professional gamers, very successful if they would go in that direction. But they're still, even if these are high professional people that cut the articles, you cannot scale that up if it's manual work. If you want to make an automated offer to new kinds of customers, you need to make it get rid of the manual stuff. So we try to build a system that can automatically cut a page of news from a newspaper into the constituting articles. Of course, the picture should belong to the article that it belongs to, not to a different one. So we need a system that somehow learns the rules of layouting by examples. We built that with a technology that was also applicable in the project we just saw on the previous slide, deep neural networks, that are pretty good at looking at images and learning what to extract from it. And they now use it. Project finished, I think, fall last year. I hope that's not wrong. And they have it in production. I just checked with them a couple of weeks ago, and they now hired 2 of my former employees and are working with it and are really happy. So we were talking about the 2 ingredients of digital innovation being scalable and aiming at automating things. I've shown you 2 examples of projects with small and medium companies, even a startup, that are building on pattern recognition technology to automate tasks you usually needed a human for, and that can be scaled. If Deep Impact uses this face verification technology rightly, they can not only use it in that specific product, they can scale it up to a worldwide market. Same with our Zurich-based media monitoring company. What do I get from this? What is my observation? My observation is the size of the idea of an innovation does not necessarily need to equal the size of the company. A small and young company with a handful of people with a good vision can aim at something that has worldwide use. That's maybe not new, but maybe new in that context, or fresh in that context. We sometimes think as, oh, is that innovation, is that idea too big for a small company? Does it need a bigger company so that the business case is somehow backed by, I don't know, more resources or something? When I look at it from a technological point of view, I see the size of the idea can be much larger than the size of the company. Why? Because in the digital innovation, the things run on a computer in the end. You don't need to buy hardware, you don't need to buy houses, you can scale up in the cloud, and you can operate it with a smaller team than in previous paradigms and in other sectors maybe. Side note to that, of course, this needs trust. If there are two young guys or ladies and they have a brilliant idea and that could scale up to a worldwide market, that could very well work from the technological point of view, but we need some trust in these people to basically entrust them with funding, with money, with the project, say, okay, it might work, it might also not work. There are no necessary reasons why it shouldn't work, but there is, of course, a risk for failure. And this is maybe smaller. The company is established, 200 years old, and has 2,000 employees. But technologically, the two ladies can do it. What else? I used, in the two examples I showed you, even in the third one we already saw, we used the same technology, deep neural networks. And we as a research group, me and my employees, we are no experts in the production industry, we are no experts in anti-money laundering or finance industry, we are no experts in print media monitoring or somewhere else in the media sphere. We are experts in building machine learning systems. But the technology is somehow independent of the industrial sector. Christoph introduced me in the beginning as being a board member of the Swiss Alliance of Data Intensive Services, one of your NTNs. And what we are doing there is we have an approach where we bring people together around topics. Cloud computing, machine learning, big data. And more often than not, people approach me after a first meeting and say, oh, that was very nice, but don't you think it's better to bring all the finance people together and talk only with them about machine learning? I say, yeah, that could be done, but I guess you get more out of it. You can answer the same questions with people from different industries. You will talk about the same stuff, and you will additionally have the added value that not all of your competitors are in the room, but people from industries that you don't bother sharing secrets with. In digital innovation, the silos of industrial sectors are less important than they have been. My observation here. Good. So we looked at 3 properties already. I have the feeling that there are things that could be improved regarding support of small and medium companies in that respect, but I leave that open to your discussion later. And go into the most interesting one, high speed. This is maybe the one that you didn't know before about, and that is not so obvious. The other 3 are obvious that this is connected to digitalization. So, what is it, high speed? Digital innovations come at a very high rate, at a very high speed. From personal observation, and not really counting the numbers, but just gut feeling, the impression that I get is what we usually build into the projects we are working on has been published on preprint servers not more than 3 months ago. Preprint servers, we're talking about where people upload their latest draft month before the final publication in a journal or conference happens. So usually we apply stuff in projects together with Swiss SMEs months before it is really published scientifically. This is an immense speed. What I've shown you here is the number of articles uploaded to that specific preprint server on which all the machine learning stuff usually ends up. These are 12,000 articles per month in this year, and it's still going up the curve. What do I get from this? There is a huge pile of ideas available, let's say, in the academic field, in the research area. Loads and loads and loads of ideas. And what is usually applied somewhere in a standard company is less. Is that bad? No, that's very good news, because all this is the gap of innovation that can be, this is an opportunity that can be used. This is what can be filled. Usually if a company comes with this level of ideas that are applied in their products, in their processes, in their services, there's a good chance that with all the ideas that are there in the sphere of research in the area of digitization, it can be improved quite a lot. Let's have a look at one more example that shows exactly this. We're working together with a startup in that case, also from the Zurich area, that want to help musicians to get rid of the pile of scores that they have to bring to their concerts. Who plays an instrument? So paper notes is nice. You can place your coffee on it, and you can take notes on it. This is all cool, but if you're playing open air and the wind comes, your notes are scattered, or you have to manually flip the pages. It's not the best we can do. Imagine you have an iPad that you can put on your music stand with all your notes on it. And now imagine it's not just the PDF that is shown. That wouldn't be digitization. That is just, okay, use a PDF. Imagine that the scores are really digitized in the way that the iPad understands what is written there. In the same way that you can have a text, like taking a picture and show it to someone, you can still read it, but the computer can do nothing with it. You have to do, OCR, optical character recognition, to transform a text to something the computer can understand and then do spell correction or whatever. We're doing the same with musical notes. We do a scanning software for an image of scores, transform it to something the machine can read, they can display it. Why? To kickstart their business model, to get into talks with publishers, to say, hey, we could scan, we're much more happy to take you on board as partners, but you have to somehow start it. So this was the idea. Why is there an Innosuisse project on it? Because OMR technology, optical music recognition, is from the 90s. As well as OCR, optical character recognition, has been from the 90s and worked okay-ish then. Well, you have a 90% recognition rate, which is great, but if you want to professionally transcribe music, like let's say for an orchestra with 120 members, 90% correct means you have a couple of notes per page that are wrong. Imagine 120 musicians, couple of notes wrong, in every measure you will have a wrong note. Not doable. You have to correct it completely by hand, helps not. So why a project? Because in many areas of computer vision, deep neural networks, we heard of them before, have completely transferred the field by working orders of magnitude better. That revolution has not taken place yet in optical music recognition, and our idea, the proposal was written, I think, 4 years ago. That was completely brand new, and we said it has to be possible, and we want to do that. So project was funded, I think, 2 years ago. Still running in its final phase, will end this year. And we started building machine learning, deep learning technology to scan pages. Now we realized the idea was very good. The pile of ideas that was available in research, deep learning, really helped to build on top of the small knowledge base that was applied in the industry. But then we faced an interesting additional thing. Computer vision for recognizing objects focused on pictures from smartphones in the real world, where usually they were resized to very small, so it's computationally feasible. And on such a picture, there may be these two guys here. So you have a picture like that, and in this, 50% of the image is taken by the two objects. So you have small images with large objects, few of them. Imagine a sheet of A4 sheet music. You have maybe hundreds to thousands of objects if every note is an object. And the A4 page is much larger than thumbnail size, resized pictures. So there are a couple of challenges in it that we still had to build on top of that already large pile of knowledge in the research area. Other things come to it. Symbols in music change their meaning according to their context. Some symbols, like the black noted, make up 50% of the data set. Others appear only twice in the largest data set on Earth that has been built, computer vision data set on Earth that has been built for that project. So lots of challenges, but thanks to a great team at ZHW, we were able to build the first object detector on the planet that can deal with bigger images and lots of small objects. We work together here with another lab of world-class deep learning researchers, and currently have a system that can, in one go, scan such a page, and it works amazing to us, equally well for printed scores and for handwritten scores. We didn't plan for that. That came with a bonus because the technology is very interesting. So what did we do here? We applied something from that pile of knowledge that was already available, and then we realized, oh, but we're not there yet. We cannot just take it and apply it. We have to build some foundations ourselves to scale it up to the real use case we saw from industry. What do I get from this? My observation. If I have to make it a pointed statement, I would say I see that there is no more a sequential process of innovation that goes from building foundations somewhere in an ivory tower, I don't know, and then do some applied research that is a little bit closer to industry, and then do some transfer that is just take it and hand it over, and it takes 10 years, and then you have a result maybe. It's somehow much more interlinked. So why is that the case? You remember that figure I showed you? The number of ideas that are available on the research sphere and the number of ideas that are applied. If there are so many ideas, why does it need foundational results for such a project? It's because of this thing is not solid. It's much more like, I think this is a Netherlands cheese, so sorry for that. You can also think that this is a real cheese? Good. You can also imagine it as a foam on your cappuccino or on your Guinness or something. The thing is, it's not solid. It has holes in it. What do I mean with that? Digital innovation is quick, very, very quick, high speed. That basically means not every gap has been filled completely until the next one builds on it. Somebody has an interesting case, a result is built, adding to the use case and to foundational results. Next one builds on it, next one builds on it, next one builds on it. There's a whole of stuff that nobody looked at. If you get an interesting use case from industry, here from that startup, scan that notes please, that musical scores, and you start to dive into the pile of ideas and research side, it's quite likely that at one place you will hit such a hole. What does that mean? You see next to it are cases that have been solved that gives you the confidence that it will work, that the project is feasible, that you can go for it and with high probability deliver something in 1.5 years or something like that. But you have to add not just to the surface of research, you have to add to quite basic results. Like in our case, we just saw object recognition methods that scale up by a large margin. And for that, we needed the largest data set on the planet for images. Okay, so this is my observation here. It's somehow basic research and applied research and transfer, they go in parallel. Not completely, but to some extent, much more than previously. So we looked at the properties. Here again, the observations I made. The size of the idea might look bigger than the size of the company that is proposing it. The technology that is used and the knowledge that is needed to bring something forward is more independent of the specific industrial sector, and the innovation process is no longer sequential. It somehow goes more in parallel. What do I get from that? Now I come to my hypotheses that may start your discussion. First, I think small and medium enterprises, first of all, need access to good networks of experts that they can ask about their ideas. Why? Because not all of innovation happens in the research sphere. I mean, I'm a researcher, I would be happy to announce that everything needs research. It's not the case. Sometimes, and we in the Alliance we have cases for that, sometimes it's completely sufficient if you can tell somebody like, hey, this exists, company whatever is selling it, go there, buy it. We heard of a company who is in the business of doing something with metal, and they just learned that what in other industries is completely common since 30 years, that using IT to support some of your processes makes you quicker. And now you can order on the website and it will directly enter the shop floor digitally without printing, handing over. It's just an IT process. We did that in the 80s, I guess. They just needed to hear that's possible and you can buy it for cheap money. That's it. What does a company need here? They need the purpose to do something. And they need somebody who tells them that it's the case. They maybe need to go to a meeting like that and hear about it. Period. Then maybe where more innovation depth is needed. You not just need to hear a keyword, you need somebody who's consulting you, who maybe comes to your company, who looks at your processes, who listens to carefully to your ideas, who brings in his expertise and uses half a day, 2 days, a week, I don't know, to really sit down with you and tell you what kind of impact will that technology have on your business model. Example for that, if you have been in the business of creating and selling hardware, and now you want to migrate your business model to not selling the hardware, but offering a service with a monthly fee. There you need business model innovation, but it goes together with hardware. Your company is expert only in hardware, not in business models. So you need somebody who tells you about it, and it needs to be looked closely at. Final stage, you have an idea as a company, you need something for it, and you find out it needs development. It needs something new to be created. You cannot buy it on the market. It's not enough to talk to people. You need research. There we are in the area of innovation projects. For example, if you have a new use case where it can be done with machine learning, for example, but it has to be adapted. You need changes to the algorithms for it to work. For example, because you don't want to train it with 1 million data points that are available in the research sphere. You need to train it on your data, and you only have 200 data points. What kind of methods are available there? How can the method be made more sample efficient? Stuff like that. So SMEs need a network of people with which they can discuss, where they can learn about things, where they can get consulting, and where they can get R&D work. And this is not just one exclusive partner, like, I don't know, my lab, or so we're not experts in everything. So this is a network of people with different skills from different backgrounds, not just academics from different backgrounds, companies, networks. Second hypothesis. We already talked about that, I hinted at it. I think in the area of digital innovation, basic and applied research somehow converge. Does not mean that they are the same, only means they converge to, they have to solve specific challenges. Some are motivated by a use case, others are motivated by furthering a method per se, but in the end, everybody needs to somehow meet in the middle, solve a specific challenge that ideally leads to products and to impacts on the foundation. Why? Because that research depth thing is our cheese or coffee foam or whatever. It has these holes. I wouldn't say this is true in every area, but this is what I see a lot in the area I have a look at in, for example, computer science aimed at machine learning and analytics. Third hypothesis. This has nothing to do with technology, and I make it very brief because this is a box. When we open it, we sit here until tomorrow. But when we talk about digitalization, we usually talk technology. I'm a technologist. That is okay. We have to talk about it, but that's not the biggest challenge. The biggest challenges we as a society will face in the next years are how we apply these technologies that have been developed. And if we only care for individuals, people, or organizations, companies, to help them how to apply the technology, these individuals will optimize what they usually optimize. The company optimizes their profit, individuals optimize their comfort, and that will not lead to the best kind of society we can have. If everybody uses sophisticated optimization technologies offered by AI and scalability to optimize his own comfort or his own profit, that will lead to a horrible society. And we need to think, and I guess Innosuisse is doing that with the area of social projects. We need to talk and to think about how can, in the area of digitalization, things be funded and thought and created that benefit everybody without a single strategy, without a single optimization objective of getting more money, making a single company successful. I heard a phenomenal talk on that the other day. It's on the slides. I think you can have the slides later. You will make them available maybe 8 minutes or so. You can watch it. It's great. I will not talk more about it. I'm finished basically. What have been my points? I think SMEs are not in the area of digitalization, are not too different from other kinds of enterprises. They can do many things that only larger enterprises could do before. So if I could, as experts, as people involved in judging funding proposals, tell you, don't look too much at the size of the company. If the idea is good, if it needs innovation, if it might have a market. Why not give it to an SME? Don't bother if it might need a bigger company for that. The affiliation to a specific industry sector by the partners in a project might be less important in that specific area than it has been under different paradigms in different sectors and earlier. And last point, if innovation involves research, so it's not just consulting, going to a meeting that Innosuisse sponsors, going to, done in an InnoCheck thing, but if it needs research, the research will not just be applied research, the research will be research. Means the people that are involved are researchers and they need an ecosystem where they are connected to their community of researchers. That has implications towards how to publish the work, how to find the right people for that, all kinds of stuff. We cannot go into details, but I want to give you the thought. Last thing, digital innovation, companies are not the only thing we should care about. There are things on the societal level we don't have to leave completely out of sight, even if the Swiss National Fund is setting up a large program on the societal impacts. I think it's important for every agency. Thank you for listening.
Thank you very much.